is unitless or it has units? It is arbitrary or unitary? What is the units? Very good. Concentration is the unit. What is pH? pH means negative logarithm of concentration. Log doesn't have units. The units for concentration is moles. So the unit, remember GPAT question, okay? The units for your pH scale is concentration. Anything related to concentration. Normality, molarity, moles, anything related to concentration. Okay? So anything related to concentration is the units for pH scale. It's the units for pH scale. That are the unit. This is called Sorensen scale. So what it contains? 1 to 14. One low pH, high concentration of H plus ions. 14 high pH, low concentration of H plus ions. Okay. So pH number increases, H plus ion concentration decreases. Or pH number increases, OH concentration increases. pH number decreases, H plus concentration increases. That's what you need to know here. So the middle is neutral, where your H plus and OH minus concentration is same. Okay, H plus and OH minus concentration is same. That's what it is. H plus and OH minus concentration is same at pH 7. So this is your Sorensen scale. Now, what are the methods to determine pH? So first method. What is the first method? Calorimetric and electrometric. What is electrometric? Electrometric, we have a bulb. I will be fast. You need to listen. Okay. Electrometric, we have a bulb here. In this, we have two electrodes. One is standard, one is reference. Electrode is made up of silver chloride. Silver chloride. Okay. Filled with a buffer. What is the pH of buffer? 7. See, there are textbooks, there are concepts which says that, okay, filled it with 0.1 normal HCl. There are textbooks which also say this. You filled with any concentration. Okay, what it will measure is what is the concentration difference of hydrogen ion inside and outside. Accordingly, it will give you what we say that display. What is the pH? So here we for time being will consider that the pH is 7. Okay, that for time being you will consider that the pH is 7. Now consider that the pH is 7. What pH is 7? The solution which is filled inside pH is 7. Why I am saying this? If you consider like this, next explanation will be easy. How? See, same hydrogen ion, inner and outer, means what? pH is 7. Higher hydrogen ion, pH is less. Lower hydrogen ions, pH is more. Okay, pH is more. So that's what the concept of this. I explain once again. It is made up of a glass bulb. Inside one bulb is there, outside one bulb is there. Okay, outside bulb is coated with a gel layer, and that gel layer is sensitive to H plus ions. When you insert that in water or a solution, it will attract H plus ions towards it. Okay, it will attract H plus ions towards it. Now inside also we have a buffered solution. Its pH is 7. When attracted H plus ion concentration outside and inside are equal, what is the pH? 7. More H plus, less than 7. Less H plus outside, more than 7. So depending on what is the concentration difference, there will be conductivity difference, and this conductance difference is transported to small chip, the chip will convert that difference into pH. That what is, because here all electricity is involving, hence we call this method as electrometric method. Calorimetric, a standard universal buffer solution is given either in capillary or in comparators, or you can say test tubes, comparing, hence we call it as a test tube. Now you need to add your solution to this. Test solutions you need to add. Now the test solution will convert its color. Now I want to find, color is there, how to find? I need to match it. For that what I will do, I will prepare from 1 to 14. I will add this standard universal buffer to all 1 to 14. Now everything will change its color like this. See, like this we have 1 to 14. I will add universal buffer from 1 to 14. Okay. So the actual measurements is 3 to 11, I think. You can measure only the buffer, so pH in this method. You can measure the pH accurately between 3 to 11. Why, I will tell you that one. Okay. So we have 14 tubes. Add, take 1 pH, 2 pH, 3 pH in all 14 tubes, 14 pH. Add the universal buffer. Buffer will change its color. Now test is there in your hand. You match the color. Wherever the color matches, that is the pH. We are matching color, hence we call it as a colorimetry. Color measurement, metry, colorimetry. Now to this point, sir, why it is accurate only in 3 to 11? Because at extreme pHs, either it is less or more, there is no much color change. Because it is a universal indicator, you won't find much color change. There is no difference between 1 and 2. No difference. 2 and 3, not that much difference. 3 and 4, there is difference. But 1 and 2, 2 and 3, there is no difference. Hence, by this method, you can measure. If you can find out if your eyes are very good, you are eating carrot every day, you are eating that one, your eyes is very good, then you can find out. For a normal eye, it is not differentiable. It is not, you can't able to differentiate for a normal eye. Okay, this was the reason for why we are not getting a good measurement in the pH at extremities. It is low or high. Extremities, you won't get the correct pH because there is no much difference in the color change. You can get the prominent difference in the color change only from 3 to 11. Hence, in this method, you can measure the color change only from 3 to 11 and pH also from 3 to 11. So that was the measurement. What is the next topic?
Applications of buffers.
What is the applications? See, for if you have any reaction to be carried out in particular pH, there you need buffer, chemistry. Okay, if you have any reaction, then to increase the solubility, you need to adjust the pH. If the drug is basic, if you take the pH acidic, then the drug is soluble in acidic pH. To increase the solubility, influence of pH on solubility. Next. Okay, if you are using any ointments or solutions or lotions, anything to the skin, the pH should match. If you are inserting anything into the body cavity, like suppose it is anything, the pH should same. Otherwise, it will cause irritation. That is called comforting the body. Then you can improve the purity. How you will improve the purity? Zwitterion. Biological. Best example is pepsin. Pepsin, trypsin, chymotrypsin, all are present in stomach. The pH is 1.2. They are active in only acidic pH. If you increase the pH to base, they will not act. So that what is your biological activity. Next, that's all. So this what the uses of your buffer. Next topic.
Buffer equation.
Buffer equation. Henderson-Hasselbalch equation. So how will you start? You have an acid which is dissociating to form H plus and A minus. Apply law of mass action. What you will get? H plus concentration, A minus concentration by AH concentration. Okay, I want pH is equal to, so I want H plus this side, send everything that side. H plus is equal to Ka multiplied by AH divided by A minus. Apply negative log. Negative log H plus is equal to negative log K. I will write it as Ka because it is acid dissociation constant. Okay, minus negative log AH by A minus concentration. Convert. pH is equal to pKa. I will write plus here. Log A minus by HA. Because it is negative here, to convert into positive, I need to, this one will interchange. So the ultimate equation is ionized by unionized. A minus is ionized, HA is unionized. This is your Henderson-Hasselbalch equation. It relates pH and pKa. There is method to determine pKa. What are the methods I told? That is the one method. What is another method? Spectrophotometry, potentiometry. Other than this, half neutralization method. What we will do there? We will try to match the concentration of ionized and, see, in half neutralization also what we are doing? This only we are playing with. In half neutralization method also, we are playing with this concentration only. So it may be spectrophotometric, it may be potentio, it may be conductivity or anything. You need to play with this because there is no option. You can't play with this, you can't play with this. The only option remaining is you need to play with this. Okay, so if I convert into pKa, tell me the equation. pKa is equal to pH plus log R. Now tell me, it will change. U by I. Yes, good. Why, sir? See, this will go this side, it will become negative. Minus log I by U. To convert into plus, again inverse. Okay, so by this is the equation where is, listen. First we will take an acid, we will fully neutralize. I will find what is the concentration, what is the ml required to full neutralization. Let's say the ml required is 5 ml for full neutralization. I want to half neutralize. Okay, I want to neutralize only half. Okay. For that, how much I have to take? 2.5 ml. So first you carried out a neutralization that you need to throw out. What you people did is, whatever neutralized, you took that, half of that you added to the another. I don't know what is this. Okay. So 2 conical flasks you should take, add acid, add base till full neutralization, stop it. Note down the reading. You need to pour this in sink, then wash, come back, add same acid in same volume, then add half of the full neutralized amount of base to it. Means what? This one is half. What should be the other one? Half. Half by half, 1. Log 1, 0. Then it will become pK is equal to pH. Go and measure pH. Second one you should not throw out. You should go and measure the pH. If you measure the pH, your pH is equal to pK. That was the logic behind that. We use logic. What is the logic we use is, if I can take same concentration in numerator and denominator, it will become 1, log 1 will become 0, this whole unit will become 0, then whatever the pH I measure is equal to pK. Whatever the pH I measure is equal to pK. That what the half neutralization method is. Next. Buffer capacity. See, you have a buffer, you are adding an acid of 0.1 normal. Okay, you are adding an acid of 0.1 normal. Now, you may add in two forms, 1, 2, 3, 4 ml, or you may increase 0.1, 0.2, 0.3, 0.4. Okay, so that was the two patterns in which you can add an acid or base to buffer. Textbook says follow this pattern. Okay, follow this pattern. Why not this? You need to find out. I also don't know, find it out. Because in this pattern also at particular ml the pH will change. But the equation never says. The equation, okay, for that you need to understand. Okay, 1 ml of 0.1 normal. What is the concentration? 0.1. 4 ml of 0.1 normal. What is the concentration? How? Listen, 0.1 normal, 1 ml. I will add 1 ml, 0.1 normal. I will add second ml. Then also it is, I will add third ml. Find out. See, there is a confusion here to understand. Okay. Because the equation says what is the concentration of buffer added divided by what is the change in pH. The equation is not speaking about ml where we are adding here, keeping the concentration constant. In that case, if I am the textbook writer, I will say you can use ml by pH change or you can use these two. Both are buffer equations if you ask me. Okay, if you ask me, both would be buffer equation because concentration is kept constant. Only ml is increasing. You go and find out whether whatever I wrote this method is there, valid, what, when, how, who, somebody has to explain it. Okay. Because I have that basic knowledge, so I am creating the equation. The equation I create, textbook says this one, I say this one. Because you can add in this fashion or you can add in this fashion, anyone. There should be one equation, okay, which tells for the both fashion. But the problem is, first one, the concentration is constant. Only the changing value is ml. So I will change in ml divided by change in pH or change in concentration, change in pH is equal to buffer capacity. What is the units? Concentration by concentration. Here there is no units, but here ml by concentration. What is the ml by concentration? Calculate, tell me the units. ml divided by concentration. Convert this concentration into ml. Convert the concentration into ml. How will you convert? CGS. Convert the concentration into ml. Gram per ml is a concentration. You don't know that CGS system? Gram per ml. Reverse it. It will become ml square by gram. See, I am creating the units by taking the equation. I want you people to learn this knowledge. If you learn this, my sole purpose is finished. I want to pass this knowledge to you. That's all. That's what my intention is. Learn this. You can create. Creation is important. Not batting, not scoring marks. Never say your marks to me. Okay. I don't care what you marks you are getting in mid 1, mid 2 or final exam. I am not happy if you come and say, sir, I got first, more marks in PP. I am not happy person. You come and say, sir, I found this problem, I solved this. Then I will feel happy. There where your knowledge is used. I won't judge you people with your marks. Show me the result. Okay, see what I just did? We find out the procedure. From the procedure, we created the equation. From the equation, we created the units. Everything from scratch. Nothing is there. I never said that this is the equation given in textbook right now. No. There are two fashions to add it. From those two fashions, I created two equations and two units. Learn this, please. I am not saying that I know everything, I have this. No. There are my teachers who used to taught us like this. They never make us to by heart. They used to teach us how to create the equation. So I will be doing that. Please learn it. Creation is important. You need to solve the problem. Okay. What is the next topic? Any doubts in buffer capacity? Any doubts here? Buffer capacity? No. Okay. What is the next one? Buffer action? It's not there. Okay. I will tell you the action of buffer for acid. You tell me for base. Did I explain this? I explained? Okay. Washroom. Go. Okay. Did I explain that? I'll be very fast. Listen. There are two types of buffers. Acidic buffer, basic buffer. This is acidic buffer. What do you mean by buffer? Is a mixture of two things. One, weak acid. Two, salt of strong base of same weak acid. Weak acid, salt of strong base of same weak acid. That what is buffer means. Remember, buffer means mixture of two things. Weak acid and salt of strong base of same weak acid. Now, when you add this in water, this one will be CH3 COO minus plus Na plus. This is how they ionize. The thing you need to remember here is this reaction is always want to go this side. This reaction is always want to go this side. This is the basic thing you need to remember. Basic thing. If you don't remember this, gone. You won't able to write the buffer equation. Okay. Basic thing to remember is weak acid always want to associate. Salt of strong base of some weak acid always want to dissociate. Remember, why? This is very important in explaining buffer action. When you add acid, this concentration will increase. Initially only this reaction want to go this side. If you are increasing this concentration, it will happily go that side. So whatever added H plus is there, it is converted into pure weak acid. GPAT question. If I am the question paper setter, I will ask this. Added H plus is converted into what? Base. As if it is acidic buffer, it is converted into base. It converted into acid. Weak acid or weak base? Weak acid. Remember. So how can you ask? This what we will ask. If see question paper setter, he is also a human being. The thing is, while reading, he will think in a different way because he already knows everything. I know everything, hence I can think in a different way. I want you people to get this mentality. If I am a question paper setter, how I am going to ask this? For that, you should have a deep basic knowledge. Okay, so acid is neutralized. Next, you add base. Now, with the base, again acid will react. Remember this. With the base, acid will react. Who is acid here? This one. He will react with this and form plus OH minus uses to CH3 COO minus plus what? So your base is converted to what? If it is a acidic buffer GPAT question, the base is converted to acid, base, neutralized and water. Answer me. The base is converted to in acidic buffer acid, base, neutralized, water. Both are same, neutralized and water. The answer will be AB, BC, CD, BC. Okay. Biological system example is blood. Blood has two things, plasma and RBC. There are buffers in plasma, there are buffers in RBCs. So I didn't remember exactly, one is primary, one is secondary. They will try to maintain the blood's pH. Okay, 1. 2. What is the second one? Biological? Blood? Lacrimal fluid. Lacrimal fluid, we have buffers there also. Okay, now due to absorption of carbon dioxide, if it is become acidic, the buffer will not try to change the pH in the lacrimal fluid. Third is kidney, urine. Kidney is an organ, GPAT question. An organ which behaves as buffer is kidney. What kidney will do is, if urine pH increases, it will absorb hydronium ion. If OH ions are increased, see, OH ion increasing means pH will also increase. If pH increases, okay, if pH increases, the kidney will absorb the OH minus ion. Kidney will do only one thing, absorb and release, that's all. If pH decreases, it will release OH minus. So it will try to maintain the pH slightly acidic. How much is the pH of urine? 5? 6.2, 6.3 something, I don't know. That is the pH of urine. If pH increases, hydronium ion is absorbed. pH decreases, hydronium ion is secreted. So it is an organ. There is no chemicals involved. There is no weak acid and salt, strong base of weak acid is not there. That is pure organ which is maintaining the pH. So GPAT question, organ which will maintain the pH is kidney. That what is biological. Pharmaceutical you already know, I told you. Wherever you do application or anything, we need to maintain the pH. Next. Buffer and isotonic solutions. See, if you want injection, if you want to give injection, you need to match the pH of the blood and also you need to match the tonicity of the blood. Hence, you need to prepare buffered isotonic solution. If you want to give eye drops, you need to match the pH of eye, you need to match the pH of, tonicity of eye. In that case, you need to prepare buffered isotonic solution. Sir, how to prepare? First prepare buffer, then adjust tonicity. Not tonicity and buffer, no. First buffer and next tonicity. Why? The method is, first you need to prepare buffer, then you need to adjust tonicity. Not tonicity and buffer. Tell me why. This is not the method. This is the method. Why? GPAT question. While preparing buffered isotonic solution, what is the method followed? Prepare isotonic solution, adjust pH. Prepare buffer, adjust tonicity. Both. None of the above. Why? Tell. If this is why, if this is why. Which concentration?
If the concentration is high, then isolation will be high.
If you first adjust tonicity, to adjust the buffer, if you add anything, the tonicity will change. So first adjust the pH, then adjust the tonicity. You understood? Okay. If you first adjust the tonicity, to adjust the buffer, you are adding something else. For that, what happens? Tonicity will change. Instead, first prepare buffer, measure the tonicity. Due to presence of that buffer, also some tonicity is induced. Prepare buffer, measure the tonicity, then adjust the tonicity accordingly. Now, tonicity is also adjusted, pH is also adjusted. This is the reason. I repeat once again, this is not the reason, because after adjusting tonicity, if you add something else to adjust pH, it will change the tonicity. To avoid this, first adjust the pH, then adjust tonicity. See, for tonicity adjusting, you may add NaCl. It won't change the pH. NaCl is neutral. It will not change the pH. But to adjusting the pH, if you add this solution, then it will change the tonicity. So this is the correct method. That whole topic is concentrated only on the, if you study the textbook, this is what the textbook says. First prepare the buffer, then adjust the tonicity. That what is buffered isotonic solution. Adjusting the tonicity methods you need to study in first year.